Okay, let's go ahead and start. So, starting into a new chapter today. That chapter being chapter 3. Mr. Merzinski's already gone over this a little bit, but of course, I want to also give us some extra instruction on this one. So, chapter 3 has to do with basically functions, and functions is kind of a new idea for us. Uh, a function is kind of like a machine that processes numbers, and it's almost like a mix between equations and expressions. So let me show you what I mean. If I have something, and I'll go ahead and scroll down. If I have something like y equals x, oof, rough x plus 2. This is what we call a linear equation in two variables. We have two variables here instead of one like we're used to. And it says that y will be whatever x is, but plus 2. So whatever we have for x, whatever we plug in for x, y will be that, but plus 2. So if I plug in a 5 for x, x being 5 plus 2, that'd be 7. So y would be 7. So anytime that we're working with these, we are working with two different values. We have our y value and our x value. And this means some interesting things. But we'll get to that in just a bit. First thing that's important is knowing our Cartesian grid. So the Cartesian grid was developed by a mathematician in France way back named Descartes. And Descartes is famous for a few things, but in particular, the Cartesian grid. So this is an example of one right here. And what we can see on this is that we have a number line going this way, so horizontally, and then another number line going vertically. And these are labeled X and Y. So what we're saying here is that, we can graph numbers along the X number line, and we can graph numbers along the Y number line. But that means that they're going to correspond to each other. They're going to be related to each other. So we call this the x-axis, and this the y-axis. And we can have values that we can plot on here. So for instance, maybe I have the value -3, 5. So what this means is that we have a value of -3 on one of these number lines and a value of +5 on one of the number lines. Now these are all always read the exact same way. And that is that the first number is always x and the second number is always y. Okay. So I'm going to change my color here real quick. I'm going to make X red. So red. And I'm going to make Y green. Okay. So when we graph these things, we typically graph the x first. We want to find where it is. So if x is at -3, then we just look at our x number line, our x-axis, and then find -3. And so that's right here. Okay, then we want to do the same thing for y. So again, y is 5. So we would need to find 5 on our y number line, our y-axis, which is right here. Let me try that again. And graph it. Now, this is not going to show us anything. What we really want to know is the place where we have -3 for x and +5 for y. Right now, these are totally separate. We want to show where both of these are true. And so for that, we need to find the place where these intersect. So this one is going that way, and this one is going that way. So they intersect at a point right here. This is where both of them, whoops. This is where both of them are. This is where x is -3 and y is +5. Okay. So let's try a few more of these things. Let's try... Whoops, got my stroke wrong. Let's try x is 2, y is -3. Okay. So, again, I'm going to use red for x and green for y. So, red is going to be here at 2. And so if we look along our number line, our x value being 2, here's 2 right here. And then green for y, -3. So we find -3 along this number line here. -3 is right here. And where are both of these going to cross? Well, this one's going along this line right here. This one's going across this line right here. So they're going to meet right at that point in between the two of them. Switch over. So right there. Okay. So why is this important? Well, again, like I said, what we're going to be doing with these functions is we're going to be keeping track of x values and y values. So with just a normal equation, we just have x, and we can find a perfect value for x, something that makes the entire equation true, or whatever variable we have. With functions, we don't have just a single value that's going to make this thing true. We can plug in whatever we want and see what happens. Again, these functions process numbers. They're going to take numbers and do things with them. So let's take a look at that. Okay, so I've got another grid down here. And don't worry about this right now. Let's just take a look at a function. Like I said, a function is going to be some kind of thing that has two variables, y and x. So let's say that y equals, we could do like the last one just did, x plus 2. Okay? So if we have y equals x plus 2, again, what this is saying is that we could plug in a wide variety of things for x, and it will give us some answer out for y. Now here's the machine part. Y is the thing that we're going to get out. Y is the product of our machine. Whatever this machine produces, it's Y. It can produce different qualities of Y. You know, a machine can do different things. It can produce different types of the same type of product, but it's always going to be that product. It's always going to be, in this case, Y. Now the way that it makes Y is using the rules over here. These are like the parts of the machine. And this is what actually processes the numbers. So X is our input, and then here's like the little cogs going around that process the numbers. So whatever we put in for X, plus 2 is going to do its machine stuff to it, and then we're going to get Y out. So, again, this is a function. This is what processes. I shouldn't really say function. It's not quite function yet. But it is really, really close. Okay. So, let's take a look at what happens when we start plugging in different values for x. Now, like I said, we do have two variables that we're trying to keep track of. So to help us keep track of that, we have something called a t-chart. And this t-chart right here has all the x values that we're going to plug in on this side. And then on this side, we're going to record whatever y values we get out. Okay, so again, we have y equals x plus 2. And the values that we're going to plug in are negative 3, negative 2, negative 1, 0, 1, 2, and 3. In fact, any time that you're working with functions, these numbers are probably a good bet to plug in for your x values. You get to pick and choose what you plug in for x when you want to look at what the function is doing. But these are a good place to start because it has a mix of negative values, positive values, and zeros. Zero can be very important when working with functions. So again, you can choose whatever numbers you want. These are the numbers that I like to work with. Okay. So again, what we're going to be doing here is we're going to be taking each of these x values and plugging it in here. So for instance, negative 3. Plug in negative 3 for x. So what do we get? Well, that would be y. Oops, switch back. Y is equal to, remember to use parentheses when we plug things in, negative 3 plus 2. Alright, and what is negative 3 plus 2? That'd be negative 1. So y equals negative 1. And there's our first value for y. So we're going to go over here, and where we have negative 3 for x, we're going to record negative 1 for our y. And we'll keep doing the same thing for all of these values. Okay. So, negative 2 in for x. Plug that negative 2 in there. That's negative 2 plus 2. That's 0. Plug negative 1 in. Negative 1 plus 2 is 1. Plug 0 in. 0 plus 2 is 2. 1 in for x. 1 plus 2 is 3. 2 in for x. 2 plus 2 is 4. 3 in for x. 3 plus 2 is 5. Okay, so here's all the numbers that we wanted to plug in for x. Now what we can do is we can go through here and say, well, these are like those points that we were graphing. We have a negative 3 for x and a negative 1 for y. So we can find that on our grid and graph that point. So let's see, where is that? Switch that over. We've got negative 3 for x and negative 1 for y. So that's about right there. Let me try that again. Right there. Okay. Next one, we have negative 2 for x and 0 for y. So negative 2 right here for x and 0 for y. Well, that means it's right here. We're not going up any on that y-axis. Negative 1 for x, 1 for y. Negative 1, 1 is right there. Then 0, 2. Again, 0 on the x would be right here in the middle. And then 2 for y is up here. That's a bit weird circle. There we go. 1, 3. So 1. And then 3 is right here. And you can probably start to see something emerging here. Then 2, 4. 2, 4 is right there. 3, 5 is right there. So again, you probably see something emerging here, and that is a line. If we connect these dots together, they form a line. Whoops. Gives the default back. Okay. Okay, so this line is the trend that this function or linear equation follows. And that's why it's called a linear equation, because this equation will make a line. It will follow a line as we plug in different values for x and y. And in fact, we can actually extend this line past the points that we have on here. We know that if it goes like a line, it's going to keep going like a line. And so we can actually make a line like that. And so with this knowledge, we can actually predict what it's going to do next. So what happens if we plug in 9 for x? Well, it's going to go all the way up here. It's going to be at 11. What happens if we plug in negative 5 for x? Well, it's going to go down here to negative 3. So again, we can predict what the rest of this function is going to do based on its graph, which is why graphs are nice. They show us the overall behavior of one of these linear equations or functions. Okay, so I will pause for any questions anybody might have. Okay, I'm not seeing any questions, so I will move on. So, one thing to keep in mind is that we are not always going to be given something like this, where we have y equals x plus 2. This is a very nice, neat, simplified, clean linear equation here. However, we may be given things that are in this form. 2x plus 7. Whoops, 7's on the outside. Times x plus 10y. Equals 7x plus y. Okay, so we have an equation here, and it has two variables. But, again, we're going to solve this the same way as any other equation. The only difference here is that now, instead of having, just x that we need to get by itself, we have y and x. So what are we going to do? Well, the answer is basically get them to their own respective sides. Now, sometimes you want them on the same side, sometimes you don't. If I'm going to be graphing it, it's going to be that they're going to be on their different sides. However, standard form tells us to put them on one side and then have all of our constants, all of our just regular numbers on the other side. So let me show you how to do that. So we need to simplify any of our expressions here, and yeah, we can simplify this side. We need to break these parentheses open by distributing the 7 into them. Okay, so if we do that, we get 7x plus 7dy. So I'll drop down everything else. Okay. Now I need to combine any like terms that I may have. So I have like terms here, 2x and 7x. If I combine those together, that'll give me 9x. Okay. So now I need to start moving things around, trying to get this thing solved. Okay, so there's an idea with these functions, with these linear equations, that is called standard form. And standard form is to have x and its coefficient, as well as y and its coefficient on one side, and any constants on the other side. So it's kind of like when we solved for x and got it to one side and had all of our just regular numbers on the other. But slightly different. The number in front of x and the number in front of y are going to stay with those numbers. And it's because we just don't know what to divide them by, basically. So I'm going to need to bring this 7x over here with the other x's. So subtract 7x. Subtract 7x. So that'll cancel here, and then here leave me with 2x. And so now we have 2x plus 70y equals y. And again, we need to get the y with the other y. So we will need to subtract y from both sides. Again, it'll cancel here and give us 2x minus 69y plus 69y, sorry. Equals 0. So again, from this point, usually what we would do is try to divide the numbers off of x, or whatever variable we have. Well, here we have two variables. So which one do we divide off? The answer is we don't. This is the standard form. This is what we want. This is our answer. As long as we have the variables on one side and any constants on the other side, and we might have a number over here besides 0, we are in the clear. And it is okay to have these coefficients, these numbers in front of our variables. So again, I will pause real quick for any questions we may have. Okay, I see no questions, so I'll move on. Let's try another one of these. So this one will be 10x plus, 7y plus x equals 11. Okay. Same idea. We want to get the x's and y's on one side. Lucky for us, they already are. So really all we have to do here is simplify. So, let's see, we have, again, parentheses. We want to get rid of those parentheses so that we have access to the numbers inside. And we're going to do that by distributing. So distribute that 7 in. And so that's going to give us 7y plus 7x. Then drop down the rest of our numbers. Whoops. Okay. And now we need to combine any like terms we may have, which we do. We have 10x and 7x. It's going to give us 17x. And that's it. Again, as long as we have our variables on one side with any coefficients and our constants on the other, then we are good to go. We have it in standard form. So this is our answer. Let's try another. Find a good one. Yeah, I like this one. So here we have, there we go, 3 plus y squared minus y squared equals negative 5x plus 1. So, variables to one side, constants to the other. And the first thing we need to do is simplify anywhere that we can. And parentheses are always going to be a good place to start, and no different here. So we have 3 plus y squared. Well, we can go ahead and square that out. So if we square it out, we're going to get y squared plus 6y plus 9. Then drop down everything else, so minus y squared equals negative 5x plus 1. And so now we can combine any like terms that we might have, and yeah, we got y squared and y squared. And they're opposites. This is positive y squared, this is negative y squared, so they're going to cancel each other. So we just have 6y plus 9 equals negative 5x plus 1. Okay. So let's see. Again, we need to get our x's and y's to one side and our constants to the other. So I've got y here and x here. Well, that means that this x is going to have to come over here. And I got 9 here and 1 here. Well, those are both constants, which means I need to get 9 over to this side. So I am going to add 5x to this side so that I can bring it over here. And then I'm going to subtract 9 so I can bring it over here. So the 5x and the 5x cancel. The 9 and the 9 cancel. So now what we have is, let's see, 6y and 5x. That means we have 5x plus 6y equals negative 1 plus 9 is going to be negative 8. And there's our equation. Again, this is standard form. And we will see more about why standard forms is so important probably tomorrow. But for now, just remember that this is standard form. It's what we want to get it into for now. Okay. So let's see. What else do we have that we can tackle? I'm looking for a good one. Ah, here's what I'm looking for. Okay. So let's take a look at this one. Six x squared minus x minus 1 squared equals y plus 4. Okay. So I want you to take a look real quick at the ones we've done before this one. Each time that we've gotten our answer, we have something like x and y, then constant. Just x, then y, then constant. X, then y, then constant. This one's going to be a little bit different. Something is going to be slightly different about our x's and y's. So pay attention. Okay, once again, we have a binomial squared, so we're going to need to go ahead and figure out what that's going to give us. Okay, so let's see. It'll be x squared minus 2x plus 1. Don't know what happened to my brain there. Okay, then drop everything else down. All right. Now we've got this negative on the outside of parentheses, and remember, anytime that we have negative on the outside of parentheses, we want to go ahead and distribute that thing. So I'm going to distribute this negative in, which is basically going to change the sign of everything in here. So now we're going to have plus x squared. Whoops, I'm sorry, minus x squared. It started out as positive. So negative x squared plus 2x minus 1, and then drop everything else down. Okay. So now combining any like terms, I've got like terms right here, so that comes out to be 5x squared plus 2x minus 1 equals y plus 4. And now everything is simplified, but again I need to get my x's and y's to one side, my constants to the other. So I'm going to need to take this 1 away from here. It's not an x, it's not a y, it's just a 1. So I'll add 1. And y doesn't belong on this side. This is where numbers go. This is where just constants go. So y I'm going to have to subtract from this side. Okay, so 1 is going to cancel, it's gone. Y is going to cancel there, it's gone. And so now we have 5x squared plus 2x plus y, minus y, equals 5. And here's the difference. This one, again, if we look at our previous ones, we have x and y then constants. X and y then constants. Here we have x squared, then x, then y, then constants. We have an extra x term here. And that's because we have a degree of 2 for our x here. So because we have a degree 2 for x, that means that we have more than one x value. Even if there's not an x value here besides the x squared, remember it's always technically there. So if you see an x squared or a y squared or anything that is not a power 1 variable, then it is not linear. All these other ones were linear equations. They would give us a line, just a straight line. This one, however, if we were to try to graph it, it would not give us a straight line. Instead, it would give us a curve. So it is not a linear equation. It is curvilinear. Okay, so keep that in mind, because Hawks will ask that of you. So if it says, hey, is this equation linear, just look and see if you have anything that isn't a power 1. So this is 2x to the power 1, this is 69y to the power 1. Fine, this thing is linear. Again, this one, nothing weird going on. Our powers are still just 1, so this is linear. This one, linear. Our powers are 1. This one, we have this tricky x squared here, so this is not linear. Again, keep that in mind because Hawks will ask you if it is a linear equation or not. Okay, so I'm going to leave it off there for the day. Next time we'll pick up this again. We're going to be doing more graphing stuff. We're going to be getting into more of the details of functions. So I hope to see you then, and I hope you have a great day. And goodbye for now.